Today I'm going to be discussing sections 4.4 through 4.6. This covers the topics of probability multiplication, independent and dependent events, conditional probability, and also probabilities found through simulations. We're going to start off with our definitions of independent and dependent events. And these definitions are on page 176 at the top. I'll read the definition and we'll look at examples. Two events, A and B, are independent if the occurrence of one does not affect the probability or occurrence of the other. If A and B are not independent, they are said to be dependent. So independent events, one is completely separate from the other one. One has nothing to do with the other one. An example of that might be clear skies and it raining out. Because it's clear skies does not make it want to rain, right? Those are independent events. Now, if I were to look at cloudy skies and raining, because it's cloudy makes it more likely that it would rain. Thus, those are dependent events. So one's going to affect the other one. So it being cloudy outside affects the chances that it's going to rain. So those would be dependent. If it's clear skies, raining, those are independent events. One does not affect the other one. Next, we're going to talk about probability of multiplication. Many times, probabilities will simply multiply together. An example of that would be the probability of flipping a coin and having a head for the first flip and a tail for the second flip. Well, probability of a head is 1/2. Probability of a tail is 1/2. Multiplying them together, you would get your probability of a head then a tail, and that would then simply be 1/4. Next, we're going to look at conditional probability, and this definition is on page 187. A conditional probability of event is the probability obtained with the additional information that some other event has already occurred. It said B given A. That vertical line has said given that, so probability of B given A denotes the conditional probability of event B occurring given that event A has already occurred. And your definition, probability of B given A, is probability of A and B divided by the probability of A. And that's when one event occurs given that the other one has already occurred. And you just use the formula to calculate that. Also, in many of these problems, you may have to use the complement. And remember, what's the complement? The opposite. You can get the complement by 1 minus the probability of A. And you use the complement when you have the probability of one or more things, and you want the probability of getting less than 1. You would use subtraction, and you would take 1 minus. So sometimes we use the complement to save ourselves some time, or to calculate something that we can't really work with, because we may know 1/2. To get the other half, we just simply use the 1 minus. So the complement is used for that. Also, the next part is probabilities through simulations. A lot of times, probabilities can't be actually calculated, but they can be simulated. So we use a computer or some type of other device to simulate what might happen. A lot of times you key the data, like 1 might be male, 2 might be female, and you could do some type of report with that. So a lot of times your data is keyed, but it gives us an idea of what could happen. And so we can calculate probabilities through simulations. That concludes your lesson on 4.4 through 4.6.